Hi everybody, we are going to do some additional examples of using angular relationships to find the measure of angles today. Our first example is going to have two transversals in it. So we start with our parallel lines and then we're going to add two transversals. So our parallel lines are A and B and our transversals are C and D. Next we're going to number the angles we've made. So we have our two transversals. We have all of our angles numbered. So now we need to figure out the measure of each angle. So for our example, we already know the measure of angle 3 is 65 degrees. We know the angle 11 is 100 degrees. So now we need to figure out the measure of the rest of the angles here. So what I'm going to do is I'm going to take these transversals separately. I'm going to start on the left with this transversal. So I'm working with angles 1, 2, 3, and 4, 13, 14, 15, and 16. And I'm going to ignore this other transversal here because transversal D does not have any impact on the angle measures for transversal C. So we're going to pretend that this half does not exist. So let's start looking for some easy angle measurements we can know. We're going to use corresponding angles and vertical angles. So in red, I have my corresponding angles. I know that angle 3 is in the bottom right-hand corner of this transversal, right here. So I'm going to go to the second place where line C transverses that other parallel line. I'm going to go to that bottom right-hand corner, and I know that angle 15 is also 65 degrees. So now I can use vertical angles to figure out two more angles. So we can now use vertical angles, I'm going to mark them in orange, to find two more angle measures. And remember, vertical angles are congruent with one another. So angle 3 that we were given at the beginning as 65 degrees is composed of these two lines, and so is angle 1. So angle 1 is also 65 degrees. And again, working with transversal C, we can see we have another vertical angle, angle 13, again 65 degrees. So now we're going to use some other principles of angles that we know, angle relationships. We're going to be using supplementary angles, angles that make up a straight line, to figure out what these remaining angles are. And the really cool thing is we know that these angles are all going to be the same size, right? Because 65 plus something is 180, and that is vertical with that. This is a corresponding angle here, and this is a corresponding angle there. So we just have to do the math just the once to figure out what the rest of these angles are. So we know, because these are supplementary, 180 degrees is this 65 degrees plus whatever angle 2 is. If we solve that algebraically, subtract 65 from both sides, we know that angle 2 is 115 degrees. So now that we found angle 2, we know the rest of these angles. We know its corresponding angle, angle 14, is also 115 degrees. We also know that the vertical angle to number 2, angle 4, is 115 degrees. And we know the vertical angle to angle number 4, angle 16, is also 115 degrees. So just using these three types of angles, corresponding angles, vertical angles, and supplementary angles, using those ideas, we were able to solve all of these angles in transversal C. I'm going to clean this up because we've already solved for transversal C, and I'm going to give us some room to work on transversal D. So I'm going to keep this same color code because it's really easy to be able to spot how we could use corresponding vertical and supplementary angles here. So I am given one angle measure, and that's angle number 11. So what I'm going to do is I'm going to start by looking for a corresponding angle to angle 11. So our corresponding angle here is going to be in that same lower right-hand corner, and that is going to be on transversal D. This time we're going to ignore transversal, see, like it's not there. So our corresponding angle to angle 11 is angle number 7. So then we can use the idea of vertical angles to find 2 more angle measures. So now we're to the point where we've used all the corresponding and vertical angles that we can, and we need to move on to using supplementary angles. And luckily these are some really nice even numbers for us to work with. So we know that we have a ton of linear pairs, right? Adjacent angles that add up to 180. We can go side to side, we can go up and down with linear pairs. It doesn't matter if you go horizontally or vertically. So in any case, I'm just going to pick angles 10 and 11. So at the beginning we were given 11, which is 100 degrees. Well, if 11 and 10 are going to add up together, they're supplementary, so they add up to 180 degrees. We know angle 10 must be 80 degrees. So now we can go through using corresponding angles, using vertical angles, to figure out the rest of these unknowns. And as we remember from before, they're all going to be congruent because they're corresponding or they're vertical. So there you have it. So we're starting out with a new example, and we have a bunch of lines, L, M, N, P, and Q, and transversal T. So we're going to start by adding the known angles that were given in the problem. So here we're given the angles, one angle for each place where this transversal meets a line. So we're going to use the types of angle relationships we know, linear pairs, vertical angles, complementary angles, supplementary angles, corresponding angles. We're going to use those types of angles that we know about to be able to reason through what line is parallel with this top line. So I'm actually going to underline this one with another color. So remember, this is our frame of reference. We're trying to figure out what is parallel to line L. So we're going to use what we know about angles to figure out what's parallel here. So we have a transversal with parallel lines. There are some rules. So we know that when a line transverses two parallel lines, it's going to create corresponding angles. So the idea of corresponding angles is that when we have an angle, this upper left-hand corner of the transversal, that means that where this line T transverses a parallel line, it will have an angle of the same measure, congruent angle in the upper left-hand corner. So let's check it out. So we've got our upper left-hand corner is 110 degrees, so it's not possible that this one is parallel, and because we're working with a whiteboard, I'll just erase this one because we know it's not parallel. So line M is not parallel. What about line N? Well, this should be 120 degrees, and that's only 100. They're not parallel lines. Line L and N are not parallel. Otherwise, this upper left-hand angle would be 120 degrees. So we can get rid of this one too. Sorry, line N, you are not parallel to line L. Now, let's look at line P. Well, on line P, we don't have that corresponding angle, so we're going to skip it for now. Now let's look at line Q. This corresponding angle, the upper left hand, is 60 degrees, where this one is 120 degrees. Okay, this one can't possibly be parallel. Sorry, line Q. Well, now we're left with line P, and we know that it's maybe parallel, but maybe none of these were parallel to begin with. So what we can do is we can use another kind of angle. What we can do is we can use another kind of angle pair to figure out if line L and P are parallel. So if we look at this, they're not corresponding angles given, so you can actually use what you know about angle relationships to get a little bit more information on the angles where T meets line L. So I'm going to add what I figure out in light blue. These are my calculations. So I'm going to use the idea of supplementary angles to figure out what these other angles are. So I know that this angle and this angle have to add up to 180 degrees. So if this one is already 120, this angle here is another 60 degrees. And I'll just go clockwise to figure these out. Well, I can use vertical angles to figure out this one. So this angle is 120 degrees. And I can use vertical angles here to figure out that this angle is also 60 degrees. So now let's check back in with line P. Well, oh wow, we have a pair of corresponding angles. So we know that these are parallel lines, and we can prove it by doing the same process here, using supplementary angles, using vertical angles to find the rest of these angles to show that these are parallel. They do have the same 4 angles. So this is our last example. It's a parallelogram, it's got some given angles, and it looks so different than the other transversals we've been working with, but is not that different than our first example. So what we can do is we can actually extend these lines to make it look more familiar. So this might look a little messy, but we can start to use some of the angle relationships we know that are easy to work with to see if we can figure out some of these additional angles. So I'm going to start with some corresponding angles because I find them really easy to work with. So we can take this transversal here. It's a little crooked because I'm not an amazing artist, but you get the picture. This in an ideal world would be a straight line. I know when this line meets one of these parallels, it's going to create a 37-degree angle. So I know that this here is 37 degrees. This will also be 37 degrees. I know that when this line, this transversal hits this parallel line, it's 76 degrees. Here's that other parallel line. So this one must be 76 degrees. I then can use the idea of vertical angles to figure out a couple more angle measures. This shares the lines that make it up with this angle, so they're both 76 degrees. I can then use vertical angles on those 37-degree angles, and this angle shares its lines that make it up with that angle, so that's 37 degrees. And this angle is a vertical angle with this, so that's also 37 degrees. So finally, we can use the idea of supplementary angles to figure out the last angle here. So I know that these 3 angles together are 180 degrees. So I'll use a little bit of algebra to solve it. So I know that 180 degrees equals 37 plus 76 plus whatever this is. So I can use some algebra to figure out that this unknown angle is 67 degrees. I then can use a corresponding angle to know that this is also 67 degrees. Then I use my vertical angles to find these 2 measures, also 67 degrees. We can use these same ideas to find the measure of these angles. So let's start with our corresponding angles because they're the easiest to find. I know when this transversal here hits these lines, that lower left-hand angle just below the parallel line is 25 degrees. So I follow it down. The lower left-hand angle just below the parallel line is 25 degrees. I then use vertical angles, if I can, and I find that these lines make up that 25-degree angle, so we've got a vertical angle on our hands right here. We also have another vertical angle on our hands here. This line here is made up of these 2, so this must be 25 degrees. So, we're stuck. How do we figure out what this last bit is? Because we don't have any more angles that we can use. So here we're going to use a principle of four-sided figures. So I'm going to clean this diagram up because in order to find these last two angles, which we know are going to be congruent, we need to use some new information. So here we can see some of those angles that we figured out weren't directly related to what was inside. Some of those angles just helped us find. We used some of our corresponding angles to then find vertical angles, and those vertical angles that we found are the ones that are in here. So what we did on the outside was a little bit of extra work, but it's what helped us find the measure of these. So in order to find those last two angles, we need to remember something about four-sided figures. For four-sided figures, like squares or rectangles or parallelograms, their angles on the interior are always going to add up to 360 degrees. So now what we're going to do is we are going to figure out whatever is left. So I set it equal to 360 degrees, and I actually find that I can multiply 2 times whatever those three add up to, because they're two 76s, they're two 37s, they're two 25s, and they're two unknowns, and our unknowns are congruent. What I can do is I can start by simplifying this. So now that I have this simplified, I just added those three together. I can start to solve for x. So now I'm going to start by getting this 2 out of here. So I'll divide both sides by 2. So then I just subtract the 138 from both sides, and I get x equals 42 degrees. So what that means is both of these angles are 42 degrees. So finally I have everything in this parallelogram figured out, and I did that using a few ideas. I did it using the idea of transversals. I did it using corresponding angles and vertical angles. And finally, the last thing I did is I used my knowledge of the sum of angles in four-sided figures, which is 360 degrees. And that's going to be important on some of our examples that we do for our assignments. So ladies and gentlemen, I hope that this was a helpful video with some good examples for you to understand how to use angle relationships to solve problems. All right, so thank you very much. Have a good day, be kind, and work hard.